age to the dark age to the Renaissance and in the modern era. Different technologies have specified each era and helped us improve as a people. I've read years ago a very excellent book by Neil Stephenson called The Diamond Age. The Diamond Age predicted correctly that we would go through an age where we can actually manufacture diamonds or nanotechnology. It also quite explicitly describes how we would do cloning. And it's an excellent book, and it's almost prescient how he predicted how things that we're actually going through now. I'd like to tell you that right now we are going through the data age, where we use the cloud, the data, actually to help us to take to the next level. And here I have a cloud in the shape of Batman, and you'll find out why a little bit later. The data age. What defines the data age, and why am I so excited about it instead of a technical talk? Well, the data age, first of all, every age that we have as a culture, there's a discovery that defines that age. The data age is not the information age. It's not software. We have some very excellent, very powerful software, but it's not about software. It's not just another data warehouse either. It's about data big, and that's why I inverted the words, because it's not about big data. It's about using lots of big data, and people may call it humongous data. And what is the advantages? Every age has some sort of advantage of what defines that age, not for a single person, but for the actual people using it. The advantage of being a first mover or having an inside knowledge, or how I would show you what the actual data is so I could do the knowledge transfer. Unfortunately, there's also a disadvantage to each age, usually a job loss. When the industrial age came along, people no longer can use manual labor. We're using machines to push it about. A good example of that in the data age is privacy abuse. If anybody actually is into this space, you can actually be very scared. You can scrub the data all you want. I can find out who actually sold what. It's pretty amazing. They think they can scrub the data. To get really crazy, we can call it Skynet. And the real definition of an age is improving the quality of life for the whole population, not an individual subset in a city like this, but actually to grow the culture. We as a people have become being able to help other people. Also to be able to inspire creativity or hurt creativity like on the dark ages. And I'd like to prove to you tonight that we are actually in the data age now. Here's my first one, is that if you were to look on the job sites, today's jobs predicting about 10% unemployment, a little bit less. But in technology fields, things are still growing. This is the growth chart for just NoSQL, obviously one of my favorites. But it also shows you on the right that the number 9 and number 10 combined are cloud computing and virtualization. That's why we're here. The biggest jobs out there, the biggest growth, despite unemployment, are in the cloud. Other than HTML5, whatever the hell it is. We also have a creation of a distinct new job called a data scientist or a data visualization. To be able to take the data that you're seeing and be able to produce something from it. It's a brand new job. There's actually 63 jobs out there. Not a lot, I know, but it just started last year as a defined actual work. And here's actually another indicator that we're moving into the data age as a job level is the growth of functional programming languages. Languages that don't have side effects. They're actually functions like math. You can see here that scheme is growing very fast, and I can actually do a relative as well. If you're to understand the data age and how to analyze your data, the first part that you have to learn is game theory. Here we have Deep Blue, a machine bot created by IBM. It actually beat the world's champion in chess many years ago, although he demanded a rematch. He thought that it was cheating somehow. A few side notes that it did have the standards opening already programmed into it, and if you're to do a true analysis using just the rules of chess, you would probably not have the standard opening programmed in it. And today, there's actually a program to try to recreate this by using distributed JavaScript. Everybody, kind of like everybody logging onto Twitter and using that JavaScript to actually solve the actual next move. Because computers today can actually beat, all the computers today can beat the best players, they've actually taken the chessboard and reinvented it called Arima. They've changed how the pieces can move in this new game, and computers can't beat even a child today. So we're still staying ahead, but only by changing the rules. Ghost in the Machine. More than 30 years ago, maybe I shouldn't say that, I actually won a science fair on creating artificial intelligence. The AI engine that was there was actually just basically a subset of 20 questions. If you're a developer like me, you realize that it's just basically a very simple weighted tree sort. Not a binary tree, a ternary tree or a tuple, but it is weighted. Now, the reason why I won it wasn't because I had the best sorting algorithm or that my tree was very balanced all the time. The reason why I won it is because I couldn't figure something out. My decision modifiers would get to the end of a tree, and both ends of the tree would be weighted the same, and it wouldn't know what to do. So what I did was I cheated. I put a random number in there. But when it chose a path on that tree, it then would evaluate its solution, and then it would reweight itself. So it would use randomness rather than a robot getting stuck in a hallway, not knowing to go left or right. It just went one direction. It might not have been the right direction, but at least it kept on moving. And then later on, it learned, oh, I'm blocked at that exit, let me go the other way. So it learned, and that's why I won. This is something that I call ABC testing. A lot of people, when they do UI testing, they'll show two different presentations to the UI to different users, and they'll see which users get more effectiveness. And then once they find out the magic answer, they'll lock down that UI and they'll present that and they'll be done. I think that's wrong. I think that we should continue to have that interface. Show them something else. What if you were showing, for some reason, a lot of women your interface and that they prefer it, but later on more men are coming in? You don't know that it's actually defined. You just had that one subset. So I call it ABC testing, to be able to modify your user interface on the fly and keep on doing it. Keep on evolving. That's what we're all about. Okay, this one's going to take a little bit of explaining to do. This is actually a scene from The Princess Bride, one of my favorite movies. Here on the right we have the man in black, who's actually a good guy, and on the left we have Vizzini. The man in black wants to capture the princess here, the Princess Bride, and in order to do so, he has to have a duel of wits to the death. And what he does is that it's hard to see, but there's two cups here, and one of them he's put the poison into, iocane powder. And the Vizzini, who's supposed to be very smart, has to figure out what he knows from the man in black about where he put the actual poison. Did he put the poison in his cup, thinking that he'd be strong and be able to fight off the poison in case he had to drink it, or did he put it in the other poison because he's afraid, he's mortal? And so he's trying to trick the man in black to try to give something away about where the poison is. It's a phenomenal scene. I would suggest that you see it, but it would take 5 minutes to show you. But why I'm describing this, because what happens is Vizzini does try to find out which cup it is, and then tricks the man in black and switches the cups. And then they each drink their own cup. And Vizzini thinks that he's picked the wrong cup. But in the end, Vizzini actually dies because he's drank the cup with the poison. Well, does that mean that the man in black had the poison in his cup? No. He put the poison in both cups. He spent the last few years building an immunity to iocane powder. And why I bring that up, he put the poison in both cups, is you could believe that there is a computer program that may beat you in chess, or in checkers, or tic-tac-toe, or war games, anybody that old. There's actually a computer program that could beat you, or most humans anyways, in rock, paper, scissors. You wouldn't think that it's possible, but they actually do it. And the winning is actually by Dan Enger, and he created a program that's called iocane powder. What the algorithm does is it tries to predict what you're going to do by doing a frequency analysis. We all do that with data analysis, and also doing some history matching. But not only am I going to try to predict what you wanted, if you're going to get the cup with the poison or not, I'm going to then change my mode because I know that you're going to pick that cup, and so I'm going to switch it. So I'm going to change what I'm going to say because I assume that you're a program that's going to assume what I'm going to do. It's meta strategy. He called it iocane powder. And it's using the past performance to judge the future results, but it readjusts the strategy when needed. And whenever I have something in red here, it's one of the key founding principles that I found about the data age. It's not to stick, and I think I had it in here. Oh, well, I guess you can see it both. Is when you analyze large data sets, these are some of the examples that I'm finding as core tenets of the data age, to use randomness, to use ABC testing, and to readjust your strategy at the will. Don't stay with the strategy if it starts to fail. The biggest example of this we have is Watson, made by IBM. Beats several of the top champions in the world at Jeopardy! I mean, it was pretty amazing to watch how it can interpret the actual English on the fly and to search it. I got to be honest, and I was kind of thinking if it really was some man in the machine that was just simply better. the epitome of the mechanical Turk come back. The irony would be delicious. But this show actually reminded me of something that I saw when I was much younger. A Gary Larson cartoon. And the Gary Larson cartoon doesn't actually show Jeopardy, but it shows the current champion going against God. And it's kind of funny if you can read it from there. And it says that, that's right, the answer is Wisconsin. Another 50 points for God. And uh-oh, it looks like Norman, our current champion, hasn't even scored yet. Why I wanted to pick this is because, well, it's kind of similar because they're both playing Jeopardy. But you'll notice that when Gary Larson actually created this art, he had the idea in his head, but he didn't know how to draw it. He was very particular how he wanted to draw it. He wanted to give a presence to where God was and the look of God. Is kind of assuming how he actually did it. He also wanted to make sure that nobody was offended. He wanted to make sure that God had all the points. Not even a chance that anybody else had no points, which we can see if we go back. Not so true with Watson. So Watson's not there yet. It's not that powerful. It almost looks like we're neck and neck with some of these. And maybe he can give some of the points to them. And as humans, as a team, we won, per se. But that's very important that no matter how good the systems that we created, we remember that they're fallible because we have created them. Always know that. No matter how good your results are, you're never going to get this good. Okay, more proof that we are actually in the data age. I used to be actually very, very strong in mathematics. I love mathematics. That was until I got introduced to computers. And then I love computers, and there goes math. I can't even do the quadratic equation anymore. But it's unfortunate because I actually believe the next wave of jobs is actually math, or math is money. That's the next era where we're going to go. The proof in it is just as simple. Start off stock market quants. You know, obviously, if you can execute a stock trade faster, you're going to get more money. They can also, because they know the inside rules, just like I defined it before, insider knowledge, they know about open orders. And they can actually have leveraged buys. When they buy some stock, they actually have a put on the other side or some such sort of stuff. But to take it the next step further, there's actually people out there that have guaranteed winnings in the lottery. What? Yes. There's actually several instances of it. I only have two here. I have dates here and you can look them up. But the cash windfall for a knowing few. There's people that have analyzed the statistics of the lottery in certain cases, and they actually buy it and they win money. They don't win the big jackpot, maybe they do, but they win enough of the smaller jackpots to actually pay for it. They'll put down $300,000 at a time, knowing that they'll make money on it. They're risking that money, and they know that they'll do it. Also, somebody actually went and did analysis of some of the scratch card games and found out that they're not so random, and he could just buy which ones are the winners. So it's not just the stock market. We also have intuition. Can a computer predict, precog, to name some of the movies out there? Can it hedge the bets? Absolutely. Sort of like the iocane powder. The Guardian and the BBC both have computers, or are reported on a computer, that had actually actively predicted the Arab summer. This isn't such a big deal. If any of you know this, this is actually also art imitates life, or life imitates art. The Foundation series by Isaac Asimov. He predicts or writes in there a very good book about how cultures go through ages and how it's predictable. Just like every stock market goes up, well, it's got to come back down. It's got to go up, it's got to get back down. You can see it's cyclical, and it's very true. I mean, no matter how bad the economy gets, it'll get better next time, per se. But he's trying to predict it in 10,000 year spans and things like that. So maybe not there yet, but that's what it's looking for. You may not be able to predict what I'm doing, but as a whole, what we would do when too much economy, too much the money in Greece and what's going to happen there and things like that. I actually believe that's a core tenet of the data age, is that we can predict, and using that math, using that analysis, actually help get to the next level, see where we're going, and change that path for something better, or for some people, not so better. A good core example to set the foundation again of where we are. My first job out of college was doing some marketing analytics, or Groupons, I guess. What's old comes new again. I work for a client, and they want to drop, let's say, $2 million in a coupon drop, and they want to see how much sales it actually drives. I did a presentation to Crafts about this many years ago. Well, the coupons obviously aren't used all at once. They're used over different times, maybe Groupon, maybe. Well, what would we get? If there's 0 events, if there's nothing out there, this is our sales volume here, and it's just some made-up stuff that I did. We call that seasonality, i.e. the sales of our product that we would normally sell no matter what happens. Let's say that's the Super Bowl weekend. We always sell lots of potato chips. We don't have to do anything, we just sell it. Or it could be that there's an event. We've dropped the coupon. Here's the coupon, not on the same scale. We've pushed some money out there, some sort of marketing effort. And because of that, a little bit later, we have that push up. You notice that the coupon drop has happened after it's already started. So maybe a little bit of seasonality is already in there. How can we know that coupon drop actually affected it? Well, if we actually had eventually 2 events, and they were the similar events, the same impact. The coupon drop, same size, volume that we got sold, coupon drop later, volume that got sold. There's obviously rules on the system. If they may be able to compete with each other, coupons are specific that they may be doubled in some markets. There's rules to every system. Every system has it. But one of the key things that I learned here that's about the data age that I want to underline is my core client was a potato chip, probably the #1 potato chip in America. You could probably guess, but I won't mention them. They sold a lot of potato chips during the Super Bowl. They always had coupons in the Sunday flyers. They always had a large display. They always had a price drop. They always did that, and advertisements as well. Every single time, and they sold a lot of potato chips. Well, they came to us and they said, which one is driving more? Is it the price drop? Is it the coupons? Is it the advertising? Is it indoor display? Well, if you've done all of them all of the time, there's no way to know. So what we suggested to them is pick a market and pull off some of those impacts. Do one market that's just an indoor store display. Do one market that's just doing advertising, and see what that impact is. And then we can use that for future prediction, per se. It wouldn't be as accurate because you wouldn't have the seasonality, but they never had the courage to actually do that. They didn't, because they wanted to continue selling it, but they will never know. I mean, maybe the, other areas, like say not during Super Bowl, they had an in-store display that they could use that, but it's not the same as impactful because everybody buys potato chips during the Super Bowl. So what really happens? You got to, when you think you have the best solution to whatever you're trying to do your data analysis, you have to have the courage to experiment, to change. It's not going to be a one-part solution. That's very core for some of the work that I've done in NoSQL. Here's another example, a little out there. You have to know me a little bit. I'm giving you this equation. It's very hard to read, but that's not going to matter. We're going to go through it right now. It's a very complex, seems like a quadratic equation. Well, let's go it step by step. I'm just trying to show you that I can fit any model that you have. If you have some coupon model and you have some input, I can fit it. If you have frogs doing something and that predicts how many eggs I'm going to sell, I can fit it. This is a little proof. Well, let's take it piece by piece. This is a simple equation that draws an ellipse. We can then filter the ellipse and so that it actually has discrete endpoints, a little bit different on each endpoint. Then we can have parabolic curves that are replicating that can are mirrored on either side, and then just some lines. If we add all of these equations together, we get the Batman model. That's what this quadratic equation, comes up with. I didn't invent this. This is an actual mathematical equation that actually draws the Batman symbol. I told you I'd talk about Batman a lot. So whatever data that you have, whatever that you want to express, you give me enough information, I can fit the model. I can show you. This is, to me, is the defining characteristic of the data age. This is the race to the cure. What is the data age really going to give us? Is it going to give us a better way to sell potato chips? No. It's going to give us a race to the cure. Sergey Brin, one of the founders of Google, has Parkinson's disease. Almost guaranteed. He actually did the DNA tests. His wife founded a company called 23andMe in reference to chromosomes. And he actually knows, because his mother has Parkinson's, he has a very limited time frame. And this is a person that has the means to be able to try to fix that. Michael J. Fox also has this. He also was rich, but not as much as Sergey Brin. Sergey Brin is on a search to try to find a cure for Parkinson's. And here's an example of what they did. The traditional model would take 6 years. Google took it and Google-fied it and did it in 8 months, some of the initiative. They kind of amplified it. Trying to find a solution for Parkinson's. They didn't quite find it. And I think I know why. They've identified a gene that may relate to Parkinson's. And this is the key finding that I found. Again, I'm going to use Batman as an example. In this movie of Batman, John Nicholson is the Joker. And he is trying to poison people. And he's poisoning people by using makeup. People that use makeup or any sort of hygiene chemicals, what he's done is he's hidden a little bit of each chemical in each individual item. Like a little bit in antiperspirant, a little bit in lipstick, a little bit in hairspray. And only by using the combination of those chemicals do you have enough that you actually die. And then you go and you die and you look like the Joker when you die. That's actually in the movie. I think that's a clue. Again, art imitates life, or life imitates art. That's why we have Parkinson's. That's why we have cancer. There may be a gene that is a good indicator that you may be susceptible to Parkinson's. But what if you haven't had exposure to aspartame or caffeine? Maybe it's the combination of the Parkinson's disease with the caffeine with too much sun, or maybe smoking with too much diet soda. And I definitely know that. I firmly believe, and this isn't some cockamamie story, I firmly believe that that's why we have cancer. And in fact, there's proof on this, and I didn't make this up. There is a vaccine for cervical cancer. And what it does is it treats the virus, the HPV virus that women may get. By treating the virus, you don't get the virus. You're just immunized against the virus. You're not immunized against cancer, but the virus is the key indicator to later get the actual cancer. Also, I don't know if you've read or heard the news story, but there's actually a man that's been recently cured of leukemia. And I have here XKCD, again, comic, I'm using art to imitate life, that actually goes through it, and they're describing how, I don't know if you can read it, they used the HIV virus, and they injected this person with it in order to attack the actual cancer. And it was very successful. Actually sounds, so if you don't think that we're about to cure cancer, we actually do it. You do actually have to be careful, because what we're talking about here, and even in the Batman, isn't causation, it's correlation. Having this, this gene does not cause Parkinson's. It's a good correlation. If you have this disease, there's a good chance, if you have this gene, there's a good chance that you may get Parkinson's, but it's not guaranteed. This is something, again, that I've defined as the twins problem. I imitated this from Einstein. My sisters are actually identical twins. Redheads, a lot of trouble. Nobody can tell them apart except for me. They have the exact same DNA, the exact same RNA. They look identical. But one sister actually had some of the pre-genes to have cervical cancer. They had to do a cone biopsy, and she's all right now. But some cells, when they did a pap smear, it was very malignant, and they kind of trying to be prevented. So, two identical people, as far as the nature is concerned, a DNA and RNA, identical twins. My own sisters. These aren't somebody that I don't know what I'm talking about. One could have had cancer, and one did not. Well, what's the difference? Well, the environment. There's the proof. If we can find those things that's just described in Batman, if we can find those agents that are given, we can tackle cancer. We can know to prevent that. Sergey Brin put all the power at his disposal, all his money, and he couldn't solve Parkinson's because he wasn't looking in the right direction. He was trying to do it himself. He was trying to take all the data himself. That's a key finding about the data age. I can take all the data that I have about analyzing coupons, and I can try to analyze things about coupons, but I'm never going to cure cancer. Okay? And even people that are doing cancer research may not be able to cure cancer if they don't have my credit card receipts to know that I eat a lot of Chinese. Maybe that it's the MSG that's causing cancer. They won't know that. They have my medical records, but they won't know I eat a lot of MSG. Only by combining multiple data sets, and that's what I mean by data big. By combining more than one data set, can we actually be able to solve this? And this is where I'm trying to say for Google. Okay, here's the bad side of the data age. What is the danger? And this is a very ugly slide, and I do apologize for it. I tried to fit everything on here. Lies, damn lies, and statistics, to quote Twain. My mother used to tell me that be careful when I'm on a long trip, because as you're driving home, you get tired, and 90% of accidents happen within 5 miles at home. So she had the intuition that it must be because after the long trip, just a few miles away, you kind of get tired, you kind of relax, and then you have an accident. But she kind of missed the forest for the trees. The reason why we have 90% of accidents happen within 5 miles of home is because 90% of the time, you're within 5 miles of their home. It's just interpretation. When you're analyzing the data, make sure you're interpreting it correctly. And there's also a very recent article, I try to use a lot of recent articles, about how we can actually analyze some data. And personally, I like to think that I'm open-minded about different people and races, but this is also a danger. They have cameras recording the umpires, and they've actually found out statistically significant sample, 3 S's, that's what was hard, that some umpires, when they don't know that they're actually being watched, do have an ethnic bias. If it's the same race as what they're doing, they'll actually have it. It's actually something that they can measure. And personally, that's a danger to me. And I like to think that I'm open-minded, but if you're watching me all the time and you find out that I'm actually have a bias for something, then I don't want to know. Dangerous. Another very good, powerful thing that you probably all know about the cloud is watering down the soup. If you put your data up on a cloud, who's to know if they're not going to have several virtual servers on there? How do you know? Well, one of the things that I'd like to do in the NoSQL Alliance is create an actual standardization of CPU per memory cycles, a measurement on each virtual machine to know you're getting your bang for your buck. If they kind of, throw 5 other people on there, that's fine, but the amount of money that you're going to pay. So just be careful when you're putting your stuff on the cloud. They may actually water down your soup. They may put 1,000 people on there. Also, I don't know if you know this, but I just invented a new search algorithm. And dummy me, I put it on Google Apps to be able to host it. And so many in Google saw my really cool search algorithm and stole it. That didn't really happen. But what I'm saying is, if you're going to host your data in the cloud, if you're going to host your applications in the cloud, always remember that the engineers at that hosting company may have privileged information. If you're about to sell 1 million shares of stock, you've got to be careful and make sure you're encrypted 3 ways to send it. Also, you got to be careful for failure. Amazon, probably the strongest cloud provider out there, other than Scale Out, of course. Just this week, and again, I try to pull very relevant information whenever I do a talk, there were 3 major downtimes from Microsoft, Google, and Amazon, all in the same week, just this week. So my example is, I was trying to say what you should do if you're going to put your data and your applications in the cloud, use multiple providers. I guess it wouldn't. I mean, this isn't really, it's Google Docs, so maybe it's not really hosting your applications, but it is significant. The only way to know is to put it in both cups, put the poison in both cups. Another interesting thing about data is if we can have reproducible results. And this is actually one of my childhood fantasies was the cold fusion. I always wanted to believe that cold fusion was a possibility when I came out with it. But nobody could ever actually prove that it actually worked. Oh, sure, it worked in a lab setting. They did The Guardian did a study that 50%, half of all the papers out there could not be reproduced. All the scientific papers published last year, half of them, they went through them very itemized, in a specific subset, not all the papers in the world, could not be reproduced because the people that were doing the analysis didn't realize when they're comparing 2 sets, they also have to do an analysis of the difference of the sets, not just versus each other. They didn't realize that. Another very good example of reproducible results, and I'm a firm believer of this, is climate change. And this is also another key indicator. If you find a result that you check and you verify, and you have other people check and verify, and they can reproduce it, don't lie to yourself and tell people that it's not happening. Grab the bull by the horns and actually solve it. And this is something that we can solve with the data age as well. I don't know if you believe it, and again, it's a political agenda, but I believe that, yes, we're screwing up the environment and it's impacted by humans. I firmly believe that. We're going to be able to prove it mathematically, so even Ronald Reagan would have approved it, I guess. But we're ignoring it because it's too scary. We don't want to deal with it, or people are politics are getting in place. If you have a result, if you have an application that's giving you an answer, and you verify it and have everybody answer, don't ignore the answer. Even if it's not the answer you want, act on it. Big data danger. I've talked about this, Skynet, or another example here is the Matrix. I do not believe that we're going to have some magical artificial intelligence that will take over the world yet. I believe that we're going to screw up enough ourselves. And there's going to be many times. We're going to put data in the cloud, and we're going to lose everybody's credit card information in an instant. Something silly like that. Or somebody's going to pull that one plug in Amazon, and everybody's going to disappear, or something like that. I firmly believe that what the Matrix to me is the financial crisis it is today. And again, I also have some other people that actually back me up. I believe where we are today is actually economic warfare. There is somebody out there that knows this economic system better than me. Hell, I can't even balance my checkbook. But there's somebody out there that is a quant, that is manipulating the system, and they're getting money. Just like the traders, they know when to sell. I can't have that knowledge. There's somebody raking, it could be a world power, I don't know, that's raking in that money. And it could be World War III, but on an economic scale. I can't do it. But again, there's some articles that I've shown that the great bank robbery that explains about Greece and how the bankers are taking all the money and we're left with nothing, and how the economic warfare. Now, don't be impressed that I have all these articles that can prove my point. I just have really good Google. You search anything on Google, you can pretty much find it. You can find blue Christmas trees or yellow Christmas trees if you want to do it. Rule 43. If you search it, you will be able to find it. But as an example, these are all articles within the last week or the week before that are. I mean, I've changed the slides just to keep it present. This is the danger. This is the big danger that we have, is that we're currently in an economic crisis that's been manufactured. It's not a hurricane, no matter how bad the hurricane is, or the tsunami, or the earthquake. Those are horrible, horrible events. But something that is going to have more impact, actually cause more deaths worldwide, that will cause more people into starvation, that will cause an actual change to our culture, is the current economic crisis. And it was manufactured by us a second time. That's worse off to me than the climate. Even more dangerous than that, though, I hear that when the BBC has reported when algorithms control the world, what they're describing here is the hitbox machine. It's an algorithm that can predict whether a song is going to be the next hit. And that's nice if you want to sell a lot of things, but a lot of music. But I think that's what's the worst thing out of all of this. If I go from top to bottom, the worst thing that we have here is an algorithm that's supposed to, that's taking away our creativity. Taking away, would this hitbox ever create a 9 Inch Nails? Or would it be another Katy Perry bop? I like Katy Perry, don't get me wrong. She's cute. But I also like 9 Inch Nails. I like Aerosmith. You know, I mean, would it keep on producing the popular songs rather than some of the esoteric songs, 9 Inch Nails or Rage Against the Machine or something like that? If you have an algorithm creating it, it will not do that, even if you have randomness. I think that what the data age should do is it should enable us to add to our culture, to add to our creativity. It shouldn't take it away. I think that is the most dangerous part that we have in the data age. And it's actually out there, and it makes a lot of money. But now that I've scared you with what's bad about the data age, let me talk about the opportunity, what we can do to be able to make money to take advantage of the data age. At NoSQL.com, we've actually created something called the Data Mart, and I'm opening up to everybody. And it's actually what GitHub. I don't know if you use GitHub or you know what GitHub. It's a GitHub for data. It's a data store that everybody can use everybody else's data and analyze it. Now, when you write some code, it's going to be that's on the Data Mart and actually applies towards the data that's out there. So it's not just code that you give and you share out in open source. It actually is run against our data sources to give you a result. Then you can also sell that. You can actually run against multiple data sets. And we don't pick one single store, even though I have some preferences about some stores. We run it against Oracle, we run against Mongo, we run it against Couch, we run it against RAC, we run against all of them to see if we get the same results. And actually, we don't, even though it's the same data set. That's actually significant. I'm also trying to standardize what the language to me of the data age is, and to me that's obviously NoSQL. I'm part of the NoSQL Alliance. But just like I was saying before, is when you're writing a little program to find out if we can sell more cameras, if we can sell more things, my suggestion is to write multiple programs and allow them to run. One little subroutine may run faster and give you the result, but let the other ones run. If you have MapReduce, if you're doing a large cluster, let the other code paths still alive. Don't prune them. Later on, as your data grows or other people use them, they may evolve. They may allow to actually produce better results or something that you weren't expecting or may not even want. So don't allow multiple code paths. I'm also suggesting to add chaos to your system. Not try to take it away to find that one root system. Add more information in there. Add it just like the randomness I was talking about so you can find that extra information. Lastly, don't give up until you find that root cause. You may think that you have a good correlation, but keep on digging until you actually have a causation. The opportunity for the data age is also in tool sets. That's really where we're focusing. And that's where I think the opportunity is being able to be creative. I'm not just creating another NoSQL database or another database in the cloud. We're actually creating the tool set, the beauty to be able to do the art of what it means to actually doing the analysis, let's do a visualization. I think that's where we as humans can actually improve on the stack, keep on building on top of it. And here's the last part of the opportunity of the data age, is help improve our culture. Some examples that I have of this is Google's self-driving car. Google actually has a program that has a car that drives around. I actually got in an accident the other day, so I'm not so sure about their algorithms. To me personally, I would, and so wouldn't Bill Gates, the richest man in the world, have spent billions of dollars trying to cure the world of AIDS, and we have yet to do that. I would love to see that. And me personally, like I said, one of my fantasies ever since a child is cheap, reliable energy. I think that if we could have fusion, a lot of the wars would go away. We wouldn't have to fight over limited resources. I urge you to realize that we are in the data age, that you can use the cloud, the data in the cloud. Don't just solve your business problems. Look for the ghost in the machine. Look for that signal that you may not know that's there. Try to analyze something else. Bring it up to a patent. Show it to your boss, or show it, like I'm trying to do here. Try to give back. Open source your idea. Use this opportunity. It is an age that we can actually improve our culture. Again, I'm Ric Johnson from NoSQL. Thank you for your time.